Yeah, hi everyone. So now we are going to discuss the second sorting algorithm, and this one is selection sort. So in this sorting algorithm, what we are doing? So first we will find the minimum element from the array. So just let me take the example, one example. So this one is the array 8, 6, 10, 3, 8. This is the array element, and using selection sort, we need to sort this array. Okay. So first of all, let me create it. 8, 6, 10, 3, 8. So first we will find the minimum element from the array. So in the first iteration, we will find the minimum element. Okay. So as we can see from this array, this 3 is the minimum element. Okay. This is the minimum element. Min element. So according to this algorithm, we will swap the minimum element to the first element of the array. Okay. So after swapping, the array will be looking like this: 3, 6, 10, 8, and 8. Okay. Or just let me remove this 8 and put it with 9 here. Okay. 9 again, 3, 16, 8, and 9. Now for the second iteration, iteration 1, iteration 2. For the second iteration, again we will find the minimum element from the array. Okay. So as we can see, so first we can see from here, in the first iteration, this array first element is already sorted. First element already sorted. First element already sorted. And as we can see from this array, 6 is the minimum element. But we cannot swap 6 because 6 is already there in the second position. Okay. Now again, we will, so for the second iteration, the array is looking like this. Again, let me move to the third iteration, iteration 3. Okay. So for the third iteration, we will see these two element is already sorted. And we will check from the array, this one is the minimum element from here. Okay. So again, we will swap this 8 to 10. So the array will be looking like this: 3, 6, 8, 10, 9 after the third iteration. Okay. Again, we will move to the iteration 4. Iteration 4. So for the fourth iteration, again we will find the minimum element here because these part is already sorted. This part is already sorted. And we need to find the minimum element here. So the minimum element is 9. Okay. So we will swap this minimum element to this one. So what will the array will look like this: 8, 9, 10. And as you can see from here, these arrays sorted now. Sorted array. Sorted array. So this algorithm is called as selection sort algorithm. And just let me write the pseudocode for this algorithm. So first we will traverse through a loop. Okay. So we will traverse using a for loop for and I equal to 0 to the last element, till the last element. 0, 1, 2, 3, 4. We will traverse from the 0th element to the last one. Okay. Now what we will do, we will first initialize the minimum element with the outer loop. Okay, this one is the outer loop. And again, what we will do, we will traverse again, we will traverse using a for loop and j is equal to I plus 1, j less than n, and j plus plus. Okay. And if we will find that element less than minimum element, okay, then what we will do, we will put the index of that minimum element to this element. And after that, at the end, what we will do, we will swap minimum element to that index, and it will generate the answer. So just let me write the code. Just let me go there to the VS Code. Let me create a selection sort class. We clear the array. What was the array element? 8, 6, 10, 3, 9. I'll call the selection sort function, and this function will sort the array. How many element is there? 5. Okay. So I'll create the function for that. So public void selection sort was int I is equal to 0, I less than minus 1, I plus plus. I'll declare the minimum element and initialize with the outer loop for j is equal to I plus 1, j less than, and here we will check if that inner loop value is less than the minimum element, then we will assign the minimum element with that inner loop index, and at the end we will swap the value. After that we will print. We will print 5 element is there, 8, 5, 10, 3, 9. So see, now this array is sorted 3, 5, 8, 9, 8. So what will be the time complexity for this algorithm? Time complexity will be same. For the worst case, time complexity will be big O of n square because we are using two loops. So two nested loop. So that's why the time complexity will be big O of n square. And just let me take the a screenshot of this node and I'll paste here. I'll attach this node here. So this one is the code. Time complexity for this algorithm will be big O of n square and space complexity will be big O of 1. That's it. Thanks. Thanks for watching my YouTube channel. Thanks.